Algebra 2, Unit 2, Target E notes, quadratic formula, and the discriminant. Example 1a, given 14x minus 4 plus 3x squared is equal to 0, identify your ABC. All right. In order for us to be able to identify ABC, we need to first make sure that the equation is in standard form. It is not in standard form currently. So notice everything is on the left side and it is equal to 0. So we just need to arrange things. All right. So we want standard form, which is ax squared plus bx plus c is equal to 0. So we want the ax squared first. That's positive 3x. I'm just going to rearrange it. I don't need to do the opposite operation because I'm not trying to get it to the other side of the equation. I'm just trying to rearrange it within the same side. So we have the ax squared. Then we want the bx. That's positive 14x. We got that. Then we want our c, our constant, minus 4, equal to 0. Once it's in standard form, then we can identify ABC. A is 3, B is positive 14, and C is negative 4. It technically isn't necessary to rearrange it because it's already on the left side, but I do think it would make it easier and avoid small mistakes, right? Like in the current form that it's at, I could see someone trying to say that A is 14 just because it's at the front, even though it doesn't have the squared. Okay, 2a, given 5x squared minus 8x plus 5 equals 2x plus 4, identify ABC. Same mentality, we want to get it in standard form. Notice there's terms on both sides. So we're going to want to get everything to the left. Okay, this is a positive 2x, so we'll undo that by subtracting it. And on the left, I'll put it underneath the minus 8x since they're like each other. The positive 4 is a constant. To undo that, we'll do minus 4. And on the left, we'll put it under 5 since they're both constants. On the left, 5x squared had nothing to combine with, so I can bring that straight down. Negative 8 minus 2x gives us a negative 10x. And then 5 minus 4 gives us a positive 1, equal to 2x minus 2x is 0. 4 minus 4 is 0. We're left with 0. So it's now in standard form, ax squared plus bx plus c. Now we can easily identify our ABC value. So a will be 5, b will be negative 10, and c will be a positive 1. 3a, given 5x squared minus 4x plus 12 is equal to 0, substitute the values into the quadratic formula. So this equation is already in standard form. Ax squared plus bx plus c. We just need to plug the values into the quadratic formula. So first, I'll identify the ABC values. A will be 5, B is negative 4, and C is a positive 10, or sorry, positive 12. The quadratic formula is x equals plus or minus the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. So we're just going to take those values from over here and plug them into the correct spot. So we have x equals negative. Negative is part of the formula. B also happens to be negative, so we're going to have a double negative. I'll put in parentheses just to highlight that. Plus or minus b squared, so that's negative 4 raised to the second. Make sure the exponent 2 is on the outside. And then minus 4 times a, which is 5, times c, which is 12. The entire top, the entire numerator divided by 2a, so 2 times 5. Okay. Later on, we'll simplify this, but right now, all we're doing is plugging it into the correct spots. All right, 4. Determine the number of solutions for each quadratic equation. We don't actually want to find out what the solutions are. We just want to know how many they are and what type. Okay. In order to calculate this, we're going to calculate something called the discriminant. The discriminant is what's found inside the quadratic formula underneath the square root. All right, so if you remember, the formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The discriminant is just going to be this right here. No square root either, just b squared minus 4ac. So for a, first thing we want to figure out is if it's in standard form. It is ax squared plus bx plus c. Perfect. Identify your a, b, c values. A is 9, b is a negative 3, c is 2. And then we're going to calculate the discriminant, which is b squared minus 4ac. B is negative 3, so negative 3 squared minus 4 times a, which is 9, times c, which is 2. Okay. Negative 3 squared is 9. Then we want to do negative 4 times 9 times 2. That's going to give us a minus 72. Okay, and then 9 minus 72 will give us a negative 63. Okay, if the discriminant is less than 0, so b squared minus 4ac is less than 0, so if it's negative, that means that there will be no real solutions. Okay, which means we're going to have a parabola roughly like this. Okay, remember that when you solve quadratics, we want to figure out where they cross the x-axis. If we have no real solutions, that means we have a quadratic that doesn't intersect the x-axis. Also means that we're really going to have two imaginary solutions. B we'll do separately. Again, making sure that it's in standard form. Ax squared plus bx plus c is equal to 0. Identify your a, b, c values. A is a negative 2. B is a negative 8. And c is also negative 8. So the discriminant is b squared minus 4ac. B is negative 8, parentheses squared, minus 4 times a, which is negative 2, times c, which is negative 8. Okay. Negative 8 squared will give us a positive 64. Then you want to do a negative 4 times negative 2 times negative 8. And you'll get a minus 64. 64 minus 64 gives us 0. Now, when your discriminant, when b squared minus 4ac is exactly 0, that means that there will be one real solution. Which means roughly if we were to graph it, it would look something like this. Pretend it touches right there. It would only have 1 point of intersection with the x-axis, so that means that there's only one real solution. Okay. And then we have no other example here, but in the middle, if we calculate the discriminant, b squared minus 4ac, and it's greater than 0, which means it's positive, that means we're going to have two real solutions. So the graph would look something like this, which just means it crosses the x-axis 2 times. Okay, so just to recap, if the discriminant is a number greater than 0, so if it's positive, that means there's two real solutions. If it's exactly 0, that means one real solution. And if it's less than 0, so if it's negative, that means it has no real solutions, which means it has two imaginary ones. All right, example 5 says solve for x by using the quadratic formula. So we want to make sure that's in standard form. Ax squared plus bx plus c. It is. So then I would identify my ABC values. A is 1, the coefficient, right? B is negative 5. C is a negative 14. So we're going to plug that in. The formula is x equals negative b, so negative 5, plus or minus the square root, b squared, so negative 5 squared, minus 4 times a, which is 1, times c, which is negative 14, all divided by 2 times a, which is 1. Okay, so I'll do a few steps at a time to try to simplify this. On the outside, negative 5 becomes positive 5, plus or minus. Negative 5 squared is 25. Negative 4 times 1 times negative 14 will give us a positive 56, all divided by 2 times 1, which is 2. Okay. Next step is I'll work on the not the quadratic, the square root. So we have 5 plus or minus. 25 plus 56 will give us 81, all divided by 2. I could take the square root of 81 to the side to work on it. 81 is a perfect square, so it's 9 times 9. I don't need to continue breaking it down because I have my pair. I'm going to take 1 9 out. They both cancel, but remember, whenever we take the square root of a number, we end up with the plus or minus. I'm not going to put the plus or minus here because it's already here as part of the formula. So all I'm going to do is I'm going to rewrite what I had, but wherever I see square root of 81, I'm going to replace it with a 9. Then it was all divided by 2. Here I recommend separating the answer into 2 so that you can do each one separately. So we have x is equal to 5 plus 9 over 2. And we have x is equal to 5 minus 9 over 2. Okay, on the left, 5 plus 9 will give us 14. 14 divided by 2 will give us 7. On the right, 5 minus 9 gives us negative 4. Negative 4 divided by 2 is a negative 2. So my final two solutions are x is equal to 7 and x is equal to negative 2. All right, B, same thing. Solve for x by using the quadratic formula. We first want to make sure that's in standard form. So ax squared plus bx plus c is equal to 0. Identify your a, b, c values. A is 2, b is a negative 3, c is a negative 5. And we're going to plug those into the quadratic formula. So we have x equals negative 3, negative b, plus or minus the square root. B squared, so that's going to be negative 3 squared minus 4 times a, which is 2, times c, which is negative 5. And the entire thing is divided by 2a, so 2 times 2. Okay, so work on the outside a little bit. The double negative for negative 3 becomes positive, plus or minus. Negative 3 squared will give us 9. Then we want to do negative 4 times 2 times negative 5, which will give us a positive 40. All divided by 2 times 2, which is 4. Okay. Then we'll work on the square root a little bit. Plus or minus 9 plus 40 is 49. All divided by 4. I'm going to take the square root of 49 to the side. 49 is a perfect square. It's the same thing as 7 times 7. Here's my pair. I take 1 out. They both cancel. So I'm going to rewrite it as x equals 3 plus or minus. We know that the square root of 49 is 7. So it replaces it completely over 4. And then separate my two answers. We have 3 plus 7 over 4. And x is equal to 3 minus 7 over 4. So on the left, 3 plus 7 gives you 10. 10 over 4 can be simplified to 5 halves if you divide top and bottom by 2. And then on the right, we have 3 minus 7, which is negative 4 over 4, which can be simplified to just a negative 1. So your final solutions for 5b are x is equal to 5 halves and x is equal to negative 1. 5c, same thing, solving for x. Make sure it's in make sure that it's in standard form. Ax squared plus bx plus c equals 0, perfect. Identify your a, b, c values. A is 1, b is a negative 8, c is 20. Then we're going to plug those into the quadratic formula. So we're going to have x equals negative b, so negative 8 plus or minus b squared, so negative 8 squared minus 4 times a, which is 1, times c, which is 20, all divided by 2 times a, so 2 times 1. Start to simplify it a little bit. The double negative outside becomes positive, plus or minus. Negative 8 squared is a positive 64. And then negative 4 times 1 times 20 should give us a minus 80. And that's all over 2 times 1, which is just 2. Okay, then we're going to want to work on the square root. So let's simplify that a little bit. Plus or minus 64 minus 80 gives us a negative 16. Okay, I'm going to take that to the side. It has a negative, so I'm going to break that up right away to a positive square root of 16 times the square root of negative 1. I know the square root of 16 is 4 times 4. So there's my pair. I take 1 out. They both cancel. Square root of negative 1 will give me I. So I'm going to rewrite it. But now I'm going to replace the square root of negative 16 with a 4i. And that's all divided by 2. Okay. I'm going to separate this just to make it look a little bit easier. Everything in the numerator is being divided by 2. So x is equal to 8 divided by 2 plus or minus 4i divided by 2. And I'm only doing this just because I feel like it'll be easier for us to see. So then we have 8 divided by 2, which is 4 plus or minus 4i divided by 2. 4 divided by 2 gives us 2. Keep the I. So we have 4 plus or minus 2i. This would be acceptable. If you want to separate it like before, you could tell me x is equal to 4 plus 2i and x is equal to 4 minus 2i. That would be acceptable as well. 5D, solve for x. Make sure it's in make sure it's in standard form again. Ax squared plus bx plus c. It is. Identify your a, b, c values. A is 1, b is 2, and c is 6. And we're going to plug that into the quadratic formula. So x equals negative b, so negative 2 plus or minus b squared. So we're going to have 2 squared minus 4 times a, which is 1, times c, which is 6, all divided by 2a, so 2 times 1. Okay. We have x equals negative 2 outside can't be simplified because there's no double negative. Plus or minus 2 squared is 4. Minus 4 times 1 times 6 will give us negative 24. All over 2 times 1, which is 2. Okay. Then we have negative 2 plus or minus the square root of 4 minus 24, which gives us negative 20 all over 2. I'm going to take the square root of negative 20 to the side to work on it. That's going to be the square root of positive 20 times the square root of negative 1. 20 can be broken down to 5 times 4. 4 is 2 times 2. Bring down the 5 from before. There's a pair of 2's. 1 will come out. They'll both cancel. The 5 has no pair, so it stays underneath the radical. And then the square root of negative 1 becomes I. So I'm going to rewrite it. We have x equals negative 2 plus or minus. I'm going to replace the square root of negative 20 with 2i root 5 all over 2. And then I think I'll separate it to help us out a little bit. So we have x equals, everything in the numerator is divided by the 2 in the denominator. So we have negative 2 divided by 2 plus or minus 2i root 5 divided by 2. So that'll give us negative 2 divided by 2 is just negative 1 plus or minus. In your numerator for this fraction, 2 times I times square root of 5, those three values are being multiplied. So as long as I divide one of them by 2, technically I would be dividing the whole product and I should be okay. So we'll do 2 divided by 2, which is 1. We don't need a 1 in front of the I, so it'll just be I root 5. If I want to separate that into two answers, I have x is equal to negative 1 plus I root 5, and I have x is equal to negative 1 minus I root 5. All right, 5e, solve for x by using the quadratic formula. We want to make sure it's in standard form. It is not. So we need to get this positive 2x to the other side, so we're going to subtract it. Positive 3 to the other side, so we're going to subtract that as well. Put it underneath the 4x because they're like terms. Put it under the 10 because they're like terms. 2x squared has nothing to combine with, so it just comes down as 2x squared. Negative 4 minus 2x is a minus 6x, and then 10 minus 3 gives us a positive 7 is equal to 2x minus 2x is 0, 3 minus 3 is 0. Okay. Then it's finally in standard form, ax squared plus bx plus c. Identify your a, b, c. A is 2, b is negative 6, and c is 7. We're going to take those values, plug them into the quadratic formula. So we're going to have x equals negative 6 plus or minus the square root. Negative 6 squared minus 4 times a, which is 2, times c, which is 7, all divided by 2 times a, which is 2. Okay. Simplifying the outside, double negative becomes positive. Negative 6 squared is 36. Then we're going to want to do negative 4 times 2 times 7, which will give us a minus 56. 2 times 2 is 4. Okay, simplifying the square root a little bit. So we have 6 plus or minus 36 minus 56, which will give us negative 20 over 4. Take the square root of negative 20 to the side, but we figured out before that was going to be 2I root 5 from the previous example. So I can replace that. We're going to have x equals 6 plus or minus 2I root 5 over 4. I'm going to separate that just to make it a little easier to work with. We have 6 over 4 plus or minus 2I root 5 over 4. Because everything in the numerator is being divided by the 4 in the denominator. 6 over 4 can be simplified as 3 halves if you divide top and bottom by 2. Same thing to the other fraction. We're going to divide top and bottom by 2. 2 divided by 2 gives us 1. We don't need the 1 in front of the I, so we'll just be left with I root 5 over 2. Now notice both fractions still have the same denominator, so I can add or subtract the numerators. So I'll get 3 plus or minus I root 5 all over 2. Okay. And again, if you wanted to separate that, you could write it as x equals 3 plus I root 5 over 2 and x equals 3 minus I root 5 over 2.